Let's take a look at what are buffer solutions. In the previous lessons on ionic equilibrium, you first learned about how to calculate pH of strong acids and strong bases. That's part 1. And for the second part, you will learn how to calculate the pH of weak acids or the pH of weak bases. And the third part, you learn how to calculate the pH of salt solutions. Now, let's take a look at buffer solution, which is a very unique type of solution. What is a buffer? A buffer is a solution which is able to resist, it is able to resist a change in pH. That means that it is able to maintain an almost constant pH when you add a small amount of acid or base or upon dilution. Let's take a look at the two types of buffer. We have the acidic buffer and the alkaline buffer. What is an acidic buffer? An acidic buffer is a mixture of a weak acid HA and its salt A-, which is also known as its conjugate base. An example would be ethanoic acid, CH3COOH, and the salt, sodium ethanoate, CH3COO- and Na+. What about the alkaline buffer? An alkaline buffer consists of a mixture of a weak base and its salt, which is the conjugate acid. For example, the weak base, ammonia, NH3, and its conjugate acid. So the weak base is ammonia, and the conjugate acid is NH4+. So the conjugate acid is really the NH4+. Remember, the acid and the base, the weak base and the conjugate acid, they differ by 1H+. The weak base and the conjugate acid. Similarly, the weak acid and its conjugate, strictly speaking, I should not be talking about the sodium because Na+ is a spectator ion. So for the conjugate base and the weak acid, they also differ by 1H+. So we have an acidic buffer, we have an alkaline buffer. And the key thing to note here is that a buffer is a mixture. It is not a pure weak acid. It is not a pure salt of weak acid. It is a mixture. So for example, an acidic buffer is a mixture of weak acid and its salt or its conjugate base. So how does this mixture resist a change to pH? Firstly, I would just like to briefly touch on how to form a buffer. For example, an acidic buffer, you just mix the weak acid and the salt or the conjugate base. So for example, I can take this ethanoic acid, 0.1 mole per dm cube ethanoic acid, and the solid salt, 0.2 gram, and mix it together and I get the acidic buffer. You can refer to your lecture notes for more details on how to prepare the buffer. But the important thing here I want to stress is how does the buffer work? Why is it that a buffer is able to resist change to pH when I add a small amount of H+ or base? Let's take a look at a buffer in action. So first of all, you can see that this buffer here, this acidic buffer, I call this an acidic buffer. It has got the weak acid and its conjugate base, which is this. It is a mixture. All buffers are a mixture. So why is it able to resist pH when I add a small amount of OH-? Let's take a look. Because when I add OH- is base, who will react with it? Obviously, something inside the buffer must have consumed and reacted with the OH- such that it is removed from the solution. If not, you know that the pH will go up. Let's say I add OH- to water. Definitely your pH will go up. But why is it when I add OH- to a buffer, pH is roughly constant? Because when I add OH- to a buffer solution, the weak acid will react with base. Acid and base reaction occurs. So OH- is the base, so it will react with the acidic component of the buffer, which is attenuate acid. And please take note that this is a football arrow to show the action of a buffer, because we're adding small quantity of base. Okay, therefore we assume that the buffer contains large quantity of both the weak acid and the salt to tackle any amount of base or small amount of base added. So when the base is added, okay, we assume that it goes to completion. All the base that's added reacts completely with the large reservoir of the weak acid in the buffer and is removed from the solution. And because OH minus has been removed from the solution, the pH doesn't change. The pOH is roughly constant, and pH is also constant. pH does not change. What about H plus? Okay, if I were to add in H plus, okay, H plus is acidic, so it will react with the basic component, which is the conjugate base. Because this is the conjugate base, right? CH3CO minus is the conjugate base. Therefore, the acid added will react with the conjugate base to remove the H plus from solution. And this arrow is a full arrow to show that it's completely removed. That's the action of a buffer. So please refer to your notes to read more about other details about a buffer. Okay? An alkali buffer behaves similarly. Okay, please go through the notes on your own and come prepared for the Olympiad lesson.